Hello everybody, welcome into another lesson. So today will be part one of a two-part lesson series on graphing systems of linear inequalities. And some of this again may seem like a review of Algebra 1. When we graphed linear inequalities and then we shaded the region that was affected, that met all the values in the specified criteria to meet both regions. So today we're only going to deal with two equation linear systems. The next lesson we'll deal with 3 and 4 inequality linear inequality systems. So here you have the system given x is less than 5 and x is greater than -4. Ultimately, we need to shade the region that meets both criteria, where x is less than 5 and x is greater than -4. The first thing you want to do is graph x is less than 5. Now, remember from when we simply graphed linear inequalities, if it's just less than and it has no equal to component, just less than, you draw a dotted line through x equals 5. So let's find x equals 5. We'll draw a dotted line through that to denote that x equals 5 is not part of the solution. If you had the equal to component, you would draw a solid line to denote that x equals 5 is part of the solution, but it's not in this case. Then we also have x is greater than -4. Well, it's only greater than -4, so draw another dotted line through x equals -4. So let's go ahead and do just that right now. Alright, so we've graphed both lines. Now, what region meets both criteria? X is less than 5. So start with x is less than 5. It's definitely going to be going this way, right? It's going to be to the left of the x equals 5 line, that dotted line. But at the same time, x also has to be greater than -4, which would be going that way. So the region that meets both criteria is going to be between -4 and 5. So what you'll do then is you're going to shade the region between here. And I'm going to try not to destroy my coordinate plane. So I'm just going to shade the region that reflects both of those, because you want to shade for all values. You want to represent all values between x equals 5 and -4. It's between and not equal to. That's why we have the dotted lines at both of those points. But the values that represent the solution to this graphically are going to be the whole shaded region between x equals -4 and x equals 5. So we'll just shade all that. And that's about what you should get there for the graph of this. So you'll shade everything between x equals -4 and x equals 5. That's exactly the graph you would get. And I do have more examples of these. So again, we're only going to deal with 2 equations today. The next lesson we'll deal with 3 and even some with 4 equations. Or not equations, but inequalities, which will really constrain our solution set even more. Just trying to do this carefully so I don't entirely destroy my coordinate plane. I certainly am not out to do that. Alright, there we go. That should put us in a better spot right now. All right. What about the next system here? I have another system that we got. Y is greater than -2. Y is less than or equal to 1. So we need, of course, to find all values where y is greater than -2 but less than or equal to 1. Well, let's start with y is greater than -2. Since it's just greater than -2, you will draw yourself a dotted line through y equals -2. So let's go ahead and do that right now. Okay, let's plot that. All right. Then we also have y is less than or equal to 1. Since it has the equal to component, you will draw a solid line through y equals 1, which will go right about there. All right. And it's a solid line with the equal to component, because if there's an equal to component, then the line y equals 1 is part of your solution set. But since y is just greater than -2, y equals -2 is not part of your solution set. Now, when it comes to shading, we need to find what meets both qualifications here. Y is greater than -2, so it's definitely going to be above the line y equals -2, but it's got to be less than or equal to 1, so it's going to be below y equals 1. So we are going to shade the region between them to meet both qualifications. And in this case, the line y equals 1 is part of your solution set, since y is less than or equal to 1. So we're just going to shade the region between these two lines. That would be the affected region. Alright, so there is your graph. There's the shaded region that represents y being greater than -2 and less than or equal to 1. And I do have more. I have about 10 more. Alright. What if we have... So we have x is greater than or equal to 0. And then we're given x plus y is less than 11. So we have this system here where x x is greater than or equal to 0. So we can picture a solid line running through x equals 0, which is essentially the y-axis. Then we also had the line x plus y is less than 11. Well, we need to graph a dotted line through x plus y equals 11 because that's not going to be part of the solution set. So let's go ahead and graph that to find the x-intercept, set y equal to 0, x would equal 11. So we will draw a open circle at the point 11, 0, 10, 11, because that's not part of the solution set. And then just to find the y-intercept, that'll also be at 11, 0, which would be right here. Draw another dot since that's not part of your set. Now draw a dotted line connecting these 2 points and through the points. All right, so now we got to shade the region that's affected. We have x is greater than or equal to 0, which is going to put you over this way. That'll put you over this way. Then we have x plus y is less than 11. Well, one thing I'm going to suggest here is convert the second equation to slope-intercept form. The second equation in slope-intercept form would turn into y is less than negative x plus 11. The reason for that, again, is because you want to figure out, are you shading below the line or above the line? Since it's less than negative x plus 11, you're going to shade below the line. So you're going to shade all x values greater than 0, but below this line here. So we will shade this region over in here. So x equals 0 is part of your solution set since it's greater than or equal to 0. Now, however, that line where x plus y is less than 11 is not part of your solution set. That's why it's a dotted line. Now, not only do you have that piece, you have all this too. Man, I'm really going through this marker. These do get pretty messy though, shading your regions. So your graph is going to look something like this. You'll of course have graphed the lines where x is greater than or equal to 0, and then x plus y is less than 11. And then here's the shaded region that meets both criteria, which will be right there. I got more. Alright, so what if we had, well, let me fill this back in. There we go. Okay, so we have x plus y is greater than or equal to negative 2. Then we also have negative 5x plus y is less than negative 3. So we have x plus y is greater than or equal to negative 2. Well, first I'm going to say we should graph x plus y is greater than or equal to negative 2. And since it has the equal to component, we can draw a solid line. So find the x-intercept. That would be, of course, at negative 2. So draw a solid dot at negative 2, 0. Your y-intercept will also be at negative 2, so draw a solid dot at 0, negative 2. Now go ahead and graph your line. Since it's got the equal to component, that's how you draw a solid line. Now, what about negative 5x plus y is less than negative 3? So, what you're going to want to do here, again, find your x-intercept. That would be at y equals negative 3, but since the whole line's just less than negative 3, it's going to be a dotted line. And you would draw an open circle at 0, negative 3, since it's not part of the solution set. That would be for your y-intercept. Your x-intercept is going to be at positive 3/5, which would be right about here. But you draw an open circle since that's not part of your solution set. Then you would draw a dotted line between them and then through them, because this line is not part of your solution set. Okay. Now, we have to find the shaded region that meets both criteria. First thing I would do, though, convert these to slope-intercept form so you know where you're shading. If you convert the first equation to slope-intercept form, that would become y is greater than or equal to negative x minus 2. You convert the second equation to slope-intercept form, that would become y is less than 5x minus 3. Alright, so y is greater than or equal to x minus 2. So that's going to be above the purple line here. That'll be above it. So we got that piece. Now we have to also graph where y is less than 5x minus 3, which would be below the line here. It'd be below the blue line and above the purple line. So here's going to be the graph of the shaded region that's affected. And there you go. There's the graph of your shaded region that's affected. That meets both of these qualifications. I got still more examples. Yes, I know, this can get messy very quickly. It sure does get messy, I do know that. Alright, let's repair this coordinate plane. There we go. Okay. What's the next system? y is greater than or equal to negative 4, y is less than negative 2x plus 10. All right, so we have y is greater than or equal to negative 4 and y is less than negative 2x plus 10. Well, first, why don't we graph the y is greater than or equal to negative 4? Since we have the greater than, we have the equal to component, it's going to be a solid line through y equals negative 4. So it's going to go like that. All right, now y is less than negative 2x plus 10. So through the line y equals negative 2x plus 10, we're actually going to draw a dotted line since that's not part of your solution set. So to find the y-intercept, you would set x equal to 0. You would get the point 0, 10. Put a open circle at 0, 10 since that's not part of your solution set. And then let's find the x-intercept, which would end up being 5, 0, which would be right here. Draw another open circle since that's not part of your solution set. Then draw a solid line, draw a dotted line rather through this since that's not part of your solution set. Okay, now for shading, we need to shade the region that meets both criteria. So y is greater than or equal to negative 4. That's going to be above this purple line. Y is greater than or equal to negative 4. But y is less than negative 2x plus 10. That's going to be below this blue dotted line. So everything over in there is going to be shaded. And you'll get the idea if I don't color it in all the way. This isn't an art class, so I'm not super worried about it. You just want to get the rough idea of the region that you're shading. So here would be the shaded region that would meet both of these criteria, would be right in there. And I have here about 7 more examples. Alright, let's fix this coordinate plane. Alright, what do we got next? So we have y is greater than 2x minus 7. We have 4x plus 4y is less than negative 12. So of course, I would start out with graphing these inequalities first. So let's start with y is greater than 2x minus 7. So since it's just greater than, you will draw a dotted line through y equals 2x minus 7, since that's not part of your solution. So let's find the x-intercept. That would end up being at 7/2. That would be, which would be at 3.5. So you draw an open circle at 3.5, 0, since that's not part of your solution set. And then, of course, find the y-intercept. That would be at y equals -7. So at 0, -7, you draw an open circle, since that's not part of your solution. Then draw a dotted line between the points and then through the points, since after all, this is not part of your solution. Alright, so there's that line. The y is greater than 2x minus 7. Now, let's draw 4x plus 4y is less than -12. So, find your x-intercept. That'll be at -3, 0, -3. And we have another open circle, since this line will also not be part of your solution set. And then find the y-intercept. That would be at 0, -3. Now we can draw a dotted line through those, since that'll not be part of your solution set. Not the best at drawing straight, but I sure do try. But anyway, there's those dotted lines. Now, if I were you, I would convert the second equation from, I would convert that from general form into slope-intercept form, which would end up being y is less than x minus 3. That's what that would convert into. So, we want to shade the region where y is greater than 2x minus 7. So that's going to be above this purple dotted line here. That'll be above it, since y is greater than it, but less than x minus 3, which would be below this, which, I'm sorry, that should be -x minus 3 still. It's going to be below that blue line, so above the purple line but below the blue line. So you're looking at this piece right in here. So that would be the area you're looking at to represent the region that meets both of those criteria. Still have 6 more. Let's just reconnect this coordinate plane here. All right. So we have y is less than x plus 4. And then we have y is greater than or equal to -2x plus 1. So we have another system of linear inequalities here where y is less than x plus 4 but greater than or equal to negative 2x plus 1. So let's start with y is less than x plus 4 and graph that. Since it's just less than, we're going to draw a dotted line through y equals x plus 4 because that's not part of our solution set. So to find the x-intercept, you would end up setting y equal to 0. That would put x equal to negative 4. So x would equal negative 4 at that point. We'll draw a open circle there since that's not part of our solution. And then to find the y-intercept, set x equal to 4. Well, that'd be at the point 0, 4. So draw an open circle there since that's not part of your solution. Now draw a dotted line between the 2 points and through the 2 points to symbolize that's not part of your solution. Alright, now we have y is greater than or equal to negative 2x plus 1. Since we have the equal to component, we'll draw a solid line through y equals negative 2x plus 1. So we'll find the x-intercept. That would be at x equals 1/2, which would be right here. We'll draw a solid dot there because that would be part of your solution set. Then we'll find the y-intercept. That'd be at y equals 1, which would be right here. Then we'll draw a solid line through those because that is part of your solution set. Alright, so there's the graph of the two inequality lines. Now we need to shade the region that meets both criteria. So y is less than x plus 4 would be below this purple line here, below this purple dotted line since it's less than. But it's got to be greater than negative 2x plus 1, so it would be above the blue line. So below the purple, above the blue, is going to give you this. So this is the shaded region here that would meet both of those criteria. Should have 5 more, then we'll be done. We're over halfway done now. Okay. Let's go ahead here. Let me fill this all back in for the missing part of the coordinate plane. I think that's it. All right, what's next? So we have x plus y is greater than negative 8. Then we have x plus y is less than or equal to, whoops, positive 6, not negative. There we go. So we have this linear inequality system where we have x plus y is greater than negative 8, and then x plus y is less than or equal to 6. So let's start with x plus y is greater than 8. Since it's only greater than, we draw a dotted line through the line x plus y equals negative 8, because that's not part of your solution set. So find the x-intercept. That would be at x equals negative 8. 3, 4, 5, 6, 7, 8. And it's going to be an open dot. It's going to be an open circle at negative 8, 0, because that's not part of your solution set. And then you'll get the y-intercept at 0, negative 8. 8 in an open circle there. Since that's not part of your solution, now we will simply draw a dotted line through there to denote that this line is not part of the solution set, since it's only greater than. Whoa, I really bowed that one off, didn't I? Hang on. It's kind of hard from the side to draw this completely evenly. Best I could there. Anyway. Next we have x plus y is less than 6. So less than or equal to 6. Since we have the equal to component, we will draw a solid line through that line. So find the x-intercept. That would be at x equals 6, which would be over here. Draw a solid dot, since that is part of your solution set. Then the y-intercept would be, of course, at 0, 6. Now we can simply graph these. And in actuality, these lines are going to run parallel to each other because they have the same slope and different intercepts. So now we just need to shade the region where it's greater than, where x plus y is greater than negative 8. So that's going to be above this purple dotted line going that way. But x plus y is less than or equal to 6. It'd be below this blue line. So every area between these two lines is going to be shaded. That's the region that would represent the solution to this problem, to this system of inequalities. Just shade a little bit that's here, I suppose. It's just a little bit over here, and then a little bit here. I try not to shade over the axis itself. And then, of course, we got this piece down here that would be shaded as in between. And that would be the region that represents the solution to this system of inequalities. All right. Should be 4 more. So we have y is greater than negative 3x. And then x is less than or equal to 5y. So sometimes, yes, you will see the equations in reverse. Well, let's start with y is greater than negative 3x. Since it's only greater than, we're going to draw a dotted line through that point. So to find the y-intercept, we'll set x equal to 0. Well, that would be at the point 0, 0. So we will draw an open circle at y equals 0, or at 0, 0, since that's not part of the solution set. And then that would be the x-intercept. Let's plot an additional point here. What if x equals 1? That would be at y equals negative 3. So we'll draw an open circle there. Then we'll draw a dotted line through these 2 points, since that's not part of your solution set. Alright, so there's part of it. Now we need to figure out x is less than or equal to 5y. I would solve this for y. Whenever you have it, x is less than or equal to something with y, solve for y. Of course, we're going to do that. We know since x is less than or equal to 5y, that means 5y is greater than or equal to x, which if we do this one more time to solve for y, that means y is greater than or equal to 1/5 x. Now we have a form that we can work with. Let's go ahead and graph y is greater than or equal to 1/5 x. So, of course you have 0, 0. This time it would be solid because y being greater than or equal to 1/5 x, that line is part of your solution set. Now let's put in x equals 5. You would get a y value of 1, which would be right there. And let's draw a solid line, since this line is part of your solution set. And there's those 2 lines. Now we need to find the area that meets both criteria. Y is greater than negative 3x is going to put it above this purple line, so that's going to be to the right of it, basically. And then, then y is also greater than 1/5 x, would be above the blue line. So here's going to be the shaded region where both criteria are met. It'll be in this ballpark, right in here. So there is the shaded region that represents the solution to both of those inequalities. And now I have just 3 more. We're down to the last 3, then we're done. Alright, 3 more. So we have x minus y is greater than 7. Then we have 2x plus y is less than 8. So x minus y is greater than 7, and then 2x plus y is less than 8. So let's graph both of these inequalities first. X minus y greater than 7 is going to be a dotted line through x minus y equals 7, since that's not part of your solution. So the x-intercept would end up being at the point 7, 0. So we'll draw an open circle at 7, 0. And then your y-intercept would be at negative 7. Yeah, your y-intercept would end up being at 0, negative 7. But you draw another open circle there since that's not part of your solution. Then just draw a dotted line and connect these. Okay, now let's figure out 2x plus y is less than 8. So again, this is going to be another dotted line simply for the fact that there's no equality. It's just less than 8, so you're going to draw a dotted line. That line's not part of your solution. So the x-intercept would be at 4, 0, so we'll draw an open circle at 4, 0. And then your y-intercept would be at 0, 8, which would be right there. Another open circle. Then draw your dotted line between the 2 points and through the 2 points. And there you go. Now, again, what I'm going to recommend is that you convert both of these into slope-intercept form so you know which parts are you shading. So x minus y greater than 7, well, that's going to start out converting to negative y is greater than negative x plus 7. However, we need to solve this for just y. Whenever you have an inequality and you divide by a negative sign, you actually end up flipping the sign. This would end up turning into y is less than x minus 7. So we have y is less than x minus 7, and then 2x plus y is less than 8. This is simply going to turn into y is less than negative 2x plus 8. Now we have something we can work with. So first, let's start out with y is less than x minus 7, which is going to be below this purple line. That would be below this purple line going down here. And then y is less than negative 2x plus 8. That would be below this blue line. So here's the region that is represented when you consider both inequalities, and the region that would be your solution. You're going to be right in this region for shading all of this. So yes, there is the shaded region that makes up your solution. 2 more, then we're done. All right, 2 more, folks, then we're done. Whoops, did not mean to kick that. Okay. Hold on, let me adjust the camera since I kicked this dang thing. I hate when I do crap like that. There we go. So we have 7x plus y is less than 0. Then we have 3x minus 2y is less, am I reading that right? Yeah. 7x plus y is greater than 0, no wonder. And 3x minus 2y is less than or equal to 5. So here's your next system of inequalities. So we have 7x plus y is greater than or is just greater than 0. So this line through 7x plus y equals 0 will be dotted since that's not part of your solution. Of course, you'll get 0 for both intercepts. So the point 0, 0 will end up being an open circle there since that's not part of your solution. Now, if I put in 1 for x, I'll end up getting y equals negative 7. So that's going to end up putting me 6, 7. That'll end up putting me right here with another open circle since that's not part of the solution. Then just draw your dotted line through the 2 points. So there's your dotted line there with 7x plus y is greater than 0. Then we need to take care of 3x minus 2y is less than or equal to 5. Since it has the equal to component, you'll have a solid line through 3x minus 2y equals 5. So find your x-intercept. That would be at 5/3, which would be at 1 2/3, which would be right about here. You'll draw a solid dot there, since that is part of your solution. And then you'll end up finding your y-intercept. That would be at negative 5/2, so negative 2.5 would be right about there. Now draw yourself a solid line through those points, since that is part of your solution. And there you go. Now, in order to figure out where we need to shade, I'm going to suggest we convert these to slope-intercept form. So 7x plus y greater than 0, that's just going to give you y is greater than negative 7x. And then let's get the y by itself to start with here. That'll give you negative 2y is less than or equal to negative 3x plus 5, which if we want to solve for positive y, you divide both sides by negative 2, you'll end up flipping the sign. You would get that y is greater than or equal to 3/2 x minus 5/2. So we need to shade the region where y is greater than negative 7x, which would be, really, it would look more to the right of this purple line, which would technically be above it. And then we also need to shade the region where y is greater than or equal to 3/2 x minus 5/2, which would be above this blue line. So here is going to be the region that you would shade. The little bit in this region here, just a little bit, a lot over here. A little bit down here, a little bit through here. Whoops, I went below the line, did not mean to do that. Definitely nothing there since I went below the line. It's an easy mistake to make. Yeah, that would actually be it, because it has to be greater than negative 7x, but greater than the 3/2 x minus 5/2. So it's just going to be this slim little region here would represent the solution set. And I got one more, then we're done. All right, just let me fix this coordinate plane real quick. Last one. Negative x is less than y. And then you'll end up getting x plus 3y is greater than 8. So we need to, of course, graph the solution to this set of linear inequalities. Well, of course, both of these are going to have dotted lines since neither of the lines will be part of the solution set. If we look at negative x is less than y, of course you'll have 0, 0 as a point, so we'll draw an open circle at 0, 0 since that's not part of the solution. And then, of course, if y is 1, x would equal negative 1. So you would end up right here at negative 1, 1. And then you'll go ahead and draw your line through here. Yep, a dotted line. Because it's not part of your solution. Alright, and then let's figure out x plus 3y is greater than 8. So another dotted line because it's just greater than, there's no equal to component. So the x-intercept would be at 8, 0. 8, so draw another open circle there since that's not part of your solution. And then the y-intercept would be at 8 thirds, which would end up being at 2 and 2 thirds, which would be right about there. Another open circle. So let's go ahead and draw another dotted line. That's about the best straightness I can have. I'm not the best at drawing these straight. Okay. Now to figure out where you want to shade, I'm going to suggest again, you solve everything in terms of y. So if negative x is less than y, that means that y is greater than negative x, right? And then x plus 3y is greater than 8. This would turn into 3y is greater than negative x plus 8, which would ultimately turn into y is greater than negative 1/3 x plus 8 thirds. So we need to shade the region that meets both criteria. So if y is greater than negative x, that's going to be above this purple line, or a little bit more to the right of it, above it. And then if y is greater than negative 1/3 x plus 8 thirds, it's going to be above the blue line. So you're going to shade this region right in here. Shade this part and all up through here. And technically you'll have a little bit here too, because it's above y, of course it's above, and since it's greater than negative 1/3 x plus 8/3 and it's greater than negative x, you're going to shade that region right in there to represent your solution set. So that's it for this lesson. Next lesson will be part 2 of graphing linear inequalities, but we're going to do it with 3 and 4 inequalities in the system. So stay tuned for that. I hope everyone has a great day. Take care.